Hello, my name is Ethan.
My name is Yalaman. We are MS Data Science students studying data visualization and exploration.
In this short video, we are going to show you an alternative approach to displaying and visualizing changes in categories in the dataset with a mix of categorical and numerical data.
One common approach of doing this is using alluvial plots. These are very appealing charts that show us changes in flow over time, as an example. However, what is often left out in these plots is what factors led to those changes. For example, what numerical features or combination of these impact the change in these categorical variables. The new approach we're proposing is using animations and using a variation over a scatter plot of two impacting numerical features with a category being labeled with a color. Here's what this would look like in the end. Now to see how we did this, let's look at our R code one chunk at a time. We will use the World Happiness Report dataset that we found on Kaggle, which is also going to be included in the description below. This is a dataset that takes track of the happiness report between 2005 and 2021. Before doing anything else, we need to do some pre-processing on the data. For example, we need to convert the ladder score, which is a numerical feature, into three categories that we're trying to see the change in over time. For the sake of example and simplicity, we'll focus on the range between 2010 and 2020. However, some countries and entries have missing values, so we will need to remove that from our dataset.
So let's start by building a simple scatter plot of GDP per capita and perceived corruption, each point representing a different country. Naturally, this would look differently for each year, with some countries improving and others getting lower score year by year. If we are interested in the change between 2010 and 2020, we could try to plot two graphs and eyeball the differences. But with the arrow method, from here we can plot one graph with arrows for points that saw a change in category. The tail of the arrow will represent the location of the point in 2010, and its tip will show its location in 2020. For example, this country had no change in its happiness category, so it does not have an arrow next to it. But if we look here, the category changed, and the arrow shows us where the point moved from in the 2D space of GDP per capita versus corruption. And the color of the arrow would indicate what category this point was before. It is important to note that we had to do a bunch of filtering and concatenating different data frames that store certain information. For example, from the original dataset, we filtered out the data from 2010 and 2020, and then concatenate them again in order to correctly show the original location of the point at the tail of the arrow.
This is a good approach. However, the arrow plot alone would not be enough to make definitive observations because it could be misleading. This is because our plot would not accurately indicate a global trend. This is where an animation becomes a useful addition to the plot, as we can see a trend over the range of years. Knowing a global trend would help us interpret the arrow plot because we want to differentiate between the arrows which are part of the global trend and the ones which are not. There are some nuances that went into the implementation of this code, and the code itself would be attached to the description below. So this is our final product, an arrow plot and an animation. By looking at the animation, we can see that there isn't much of a global shift or trend, and thus looking at the arrow plot, we can conclude, for example, that most of the points that shifted to a better category from a lower category of the ladder score have a tendency of decreasing perception of corruption between 2010 and 2020, which makes sense. We can make this conclusion because we confirm that there isn't a global trend from the animation, and thus these arrows are specific for the change of category rather than the global trend of shifting the categories down.
So let's wrap things up. In the case where we want to visualize and observe changes in flow of categorical features over time, we run into a problem of missing what actually led to these changes. With our arrow plots and animation, we could see the shifts in categories while at the same time seeing what factors could have led to these changes. Here we visualize the influence of GDP per capita and perceived corruption on happiness.
This is a nice way to observe global shifts, but this chart, like the alluvial plot, would fail in showing what country each point represents. Potential improvements could include adding names to each point or incorporating other numerical features represented as the size of each data point. But we decided to omit those for now for the sake of not overloading the plot.
We hope this video helped you learn something new, an alternative approach to visualizing changes in categorical data while displaying the underlying numerical features that led to the change. You can find in the description our code.
Thank you for watching the video. Hope this was useful. Have a good day.